Hello. Next part is gravitational field intensity E is given by, it is actually, if you have gone through the definition, it is actually a force acting on a unit mass. This is the meaning. So it is given by G capital M into 1 divided by R square. So it is given by G M by R square. Now the meaning is this is a mass capital M. This is a heavy planet मान लो या तो any mass capital M, and from this capital M center at a distance smaller there is a point P in the gravitational field of this mass. This is the gravitational field of this mass, that means around this area or region the gravitational effect of this mass exists. How strong that effect is, we measure it by finding the force if we place a 1 kg mass or a unit mass at this point. So let us place a unit mass at a point P, that means small 1 equals to 1. Now what would be the force experienced by that unit mass? What would be the force experienced by this unit mass in this direction? It would be attractive. That means this is the force this unit mass would be experiencing by capital M. So this is the gravitational field intensity. Force equals to intensity, yes, because intensity by definition is a force when applied on a unit mass. The second mass has to be 1. Then the force becomes up to equal to this much, Gm by R square. Second mass becomes 1. This force is directed towards the mass. The thing is, if we consider another point here, say Q, then the gravitational field here would be directed towards the center of the capital M again, but it would be something different, say E2, and that would be given by G, okay, M, okay, divided by the distance has suppose become R dash. So R dash square. Like this, whatever would be the distance, depending on that. So gravitational field intensity would be more if distance R is less. So gravitational field intensity is given by intensity and distance is given by 1 by R square. That means like this. E proportional to 1 by R square. Field intensity 1 by R square. 1 by R rectangular hyperbola. Remember, if two quantities were inversely proportional to each other, A proportional to 1 by B, तब उसका ग्राफ कैसा होता था? A proportional to 1 by B, उसका ग्राफ ऐसा होता था, rectangular hyperbola, A versus B. But if it is 1 by R square, it would be steeper graph. Just like that, but steeper. So this is E proportional to 1 by R square graph. Gravitational field intensity. It means what? It means that the gravitational field intensity E suppose was E naught at some position. The distance was R naught. Now if the distance is made to R naught, the gravitational field intensity will become how much? Who will say this? R naught distance, gravitational field intensity E naught. 2 R naught distance, gravitational. हाँ बोलो.
Half of the field intensity.
Sir, 1/4 of field intensity.
Sir, 1/4 field intensity.
Yes, 1 by R square. So as R becomes double, so field intensity will become 1 by double square. 1 by double square means 1 by 4. Okay. So this is the idea. Gravitational field intensity, how it varies. So we can say closer we are from a planet or a mass, closer we are, strong is the gravitational field intensity. And more distance we are away from it, weaker would be gravitational field intensity. Okay. Now, there is another relation, very good relation, and you will be finding again in electrostatics. What? If gravitational field intensity is E at any position around a mass at a point P, suppose. This is a mass, it has got gravitational field around it. At any point, the field intensity is capital E. So if you place a mass at that point, then it will experience a force given by E into M. Let me explain this in easier meaning. Suppose a pen costs, say, 50 rupees. Now, if you have to buy 10 pens, what would be the total cost? You will just multiply it by the number of pens. Similarly, gravitational field intensity at a point is suppose 10 with some unit. It is 10. That means if you place a unit mass at that point, it will experience a force equal to 10. So if you place m mass at that point, it will experience a force m times of one mass. That means m into 10. That is mass on force on unit mass, that is capital E. Force experienced by a unit mass is capital E, gravitational field intensity. So force experienced by m mass will be m times of E. So F equals to E. Just remember this. I have not said as far as gravitation is concerned and board exam and normal exams are concerned, this is very important. But for competitive exams, this is important. Force equals to intensity into mass. Now, gravitational intensity E, again I am writing the formula G m by r square. We by now have understood that G is a constant, capital M is the mass for which we want to calculate or find the gravitational intensity around it at a point. And r is the distance of that point where we want to find gravitational field intensity from this mass. So that is r. So if this is the gravitational field intensity, suppose if gravitational field intensity at a point becomes 0, no gravitational field intensity, every good thing has an end, so does gravitational field intensity. If you move a long distance away from a mass, its field intensity decreases, and once it becomes 0. So if it is 0, neither G 0 nor the mass. So only way is R has to be infinite. That means लिख के रखो, just write it. Even for a small mass, its field, that is gravitational field, extends up to infinity. In bracket write theoretically. Theoretically, it will extend up to infinity, but practically, after moving a certain distance from a mass, a planet, its gravitational field nearly ends, is not felt noticeably. That is the meaning. Practically, it ends at a certain finite distance, but theoretically, it extends up to infinity. So that is one part related to gravitational field intensity. Now there is another term, new term, another new term, that is gravitational potential energy. Very, very important term. Gravitational potential energy. Let us do this. Gravitational potential energy. First write the formula, minus G capital M small m, or you can write M1 M2 also, no problem, divided by small r. This is the formula for gravitational field intensity. Potential energy, gravitational potential energy. So if gravitational potential energy, any energy negative means the energy binds the masses, the particles, the system is bound to something. Bound means if you have to release those particles or masses or anything from the system, you have to provide it with energy. Otherwise, it will not come out. That means the system is bound together. That energy becomes negative. Wherever you will get energy negative. So this energy is negative will come later. First, let us understand what is gravitational potential energy. I would suggest you, before going through those languages and paragraphs, better would be if we first derive this, then we will explain this, why, how much, like that. So just do this. Chalo, draw this. Draw a mass capital M, a little bigger mass, capital M. Then draw a straight line like this. And then draw dotted line. And then write infinite, that is infinity. That means this is very long distance away from this mass. Okay, now let us find a mass small m. It was waiting a long distance away, but this capital M mass is attracting it. As a result, this mass small m is moving towards capital M. At some instant, it came to this position, say P. So P is any position P. Any position should have any distance, and any distance which is not fixed, we take them x, y, z like these variables. So let this distance be x. At any instant we ask the mass, भाई साहब आपका ऊपर कितना फोर्स है? तो ये बोल रहा है कि देखो ना मेरे ऊपर इतना फोर्स है, कितना g कैपिटल M स्मॉल m डिवाइडेड बाय एनी डिस्टेंस स्क्वायर. ओके, किधर है ये फोर्स? बोला मैं तो अट्रैक्टेड हो जा रहा हूं, कैपिटल M इज अट्रैक्टिंग मी. ओके, सो दिस इज द फोर्स इन दिस डायरेक्शन. फिर पूछा अच्छा ये फोर्स आपका ऊपर फिक्स है कि वेरिएबल है? So this is variable force because x is variable. As it moves towards the mass capital M, its distance decreases. So as the force is decreasing, that is variable, तो ठीक है, variable force है. अब इसका साथ बात नहीं हुआ, वो फाइनली क्या किया? The mass came to a position Q. This is the final position. To position Q, and the final position is at a distance, final distance small r. So now we want to do what? We want to find work done in moving the mass small m from x equals to x equals to. Now can you say what would be these two places? From and to. What should we write? From x equals to what and to x equals to what? The mass small m has been moved.
X equal to x equal to r.
X equals to infinity to x equals to r, yes, right. So work done in bringing the mass from infinity to r, then write, let us do the derivation part, then write this thing, W equals to, as we understood from our discussion, F से बात हो रहा था ना, तो F बोला ना कि I am variable, तो for variable force, work done is given by F dx, integration F dx, and we have to put limits. Limit, lower limit and upper limit. Lower limit is the limit from where the whole situation started. It started from a distance infinity and it ends at point Q. So Q has a distance small r. So from infinity to small r. Chalo, let us do the calculation part. From infinity to small r. Let us do the calculation part. So W equals to, work done equals to, integration infinity to small r, let us put the value of f, g capital M small m divided by distance square into dx. Now for those who don't have mathematics, and for those who have mathematics, only these two categories of students, तो बचा क्या फिर? कोई नहीं. तो ये याद रखना थोड़ा, क्या इंटीग्रेशन dx by x square, it will save your time at least, minus 1 by x. ये होता है. Integration dx by x square will give you minus 1 by x. Whether you know, you don't know, doesn't matter. But if you Want to understand this? See, integration dx by x square means x to the power minus 2 into dx. And as a result, power of x increases by 1 divided by that power. So this is the result. From this we get x to the power minus 1 divided by minus 1. That means minus 1 by x. So what I tell you is to remember this thing. From this line to this line. It will save our 2 lines and a little bit of calculation. So anytime you find this thing, integration dx by x square, just put x to the power minus 1, you will be given full marks, no harm, and for competitive exams it will save your time. Anyway, so चलो तो ये लोगों से पूछते हैं कि कौन कौन कांस्टेंट है, कौन कौन वेरिएबल है। जीएमएम बोला है कि हम लोग तो सारे कांस्टेंट है, बाहर आ जाऊं, आया, बाहर आ गया। इंटीग्रेशन का अंदर dx by x square, just write once dx by x square infinity to r and then put the values. What? GMM, okay, and the integration gives us minus 1 by r, minus 1 by x. Carry the limits infinity to r. Carry the limits infinity to r. And now put the values so that you get, चलो माइनस को ना बाहर कर लो, ये माइनस को बाहर कर लो यहाँ पे. Take the minus out. So minus, then GMM. Now put r in place of x. So 1 by r minus lower limit. Put infinity in place of x. So 1 by infinity in physics we will take 0. अरे आ गया, आंसर आ गया. How? This becomes equal to minus g capital M small m divided by small r. So work done in displacing an object, in work per energy we learned that if there is a change in position or there is change in shape or size, the work done is stored as which kind of energy? Potential. That's why this work done can be written as potential energy. Now the force here is gravitation. That's why this sort of potential energy, this kind of potential form of potential energy is called gravitational potential energy. See, we had written the formula, same formula, minus GMM. फोर्स कितना होता था? जी एम एम बाई आर स्क्वायर. इट वुड बी जस्ट एक आर होगा, आर स्क्वायर नहीं, माइनस जी एम एम बाई आर, एंड माइनस ऑल द टाइम. व्हाई? बिकॉज इट इज अट्रैक्टिव और इट इज बाउंड टू अ सिस्टम. सो ग्रेविटेशनल पी के बारे में आफ्टर वी हैव लर्न दिस, वेरी इंटरेस्टिंग, वेरी मजेदार है. से दिस इज अ मास m1 एंड दिस इज अ मास m2 and they are at a distance r1. What is the gravitational PE of these two masses? So PE equals to m1 m2 divided by r1 with a negative sign. With a negative sign. So minus g m1 m2 by r1. Negative not visible clearly. अब ठीक है. Minus g m1 m2 by r1. Now, if there is another mass m3 at a distance, say r2, between m2 and m3 there is a distance r2. So there would be another gravitational PE for a combination of m2 m3 taken together. m2 m3 के लिए there would be another gravitational PE. How much? Formula same, minus g, product of these two masses m2 m3 divided by distance between those two masses you are considering, that is r2. Oh, then so there can be a combination taking m3 and m1 together. Yes, that would be. Let this distance be r3. So there would be a combination of two masses m1 and m3 like this, minus g m1 m3 divided by r3. So how many times do we need to do this? Only 3 times. Taking, say I'm using a color, taking these two together, there would be a combination. Then taking these two together, there would be a combination. And finally, taking these two together, there would be another combination. So there would be 3 like this. Actually, there would be n into n minus 1 by 2 number of combinations. You have done it in chemistry when an electron transits from nth orbit. These many types of transitions are possible. Just like that. So n is what? N is number of particles present. So n is 3 here. 3 into 3 minus 1 by 2. What is the result? 3. So we have done 3 times. If there are 4 particles like this, 4 particles, so it would be 4 into 4 minus 1 by 2. That is 6 times. You have to do this 6 times. I mean, gravitational potential energy 6 times. So just like that, run this. Let it be written here. We understood the idea कि we have to combine 2 masses together. ऐसा करके जितना बार combine कर सकते हैं करेंगे, and then we will add them together to get the total potential energy. Like minus this plus minus this plus minus this. तीनों को ऐड कर देंगे, that would be the total potential, gravitational potential energy. Why? Because gravitational potential energy, any energy is scalar quantity. So scalar quantities can always be added. That's why we will add them together to get find the total gravitational P. For an example, let us do this thing. Let us take 3 masses M, M and M placed at the vertices of an equilateral triangle. Now if I ask you what is the total gravitational PE of the system, then can you answer it? देखो तो कर सकते हो कि नहीं? Right answer. Right answer. These two would be having a gravitational P minus G. M1, M2, both are M. So M into M, M square. Divided by R square ना R square बोल ले.
हाँ सर, L square into
Sir, it will be minus 3 g n square by L.
L और को
L.
हाँ सही बोलो माइनस जी एम स्क्वायर बाई एल. यस minus g m1 m2 by r. So minus g m1 m2 by r means L here. Okay. Now if we consider these two, they will also give us a gravitational P minus g capital M, small m into small m, that means m square, divided by r. R means L again. And so for this also, these two would also be having a gravitational P just equal to this. So total gravitational P would be this plus this plus this. That is 3 into, this is the answer, 3 into minus g m square by L. If you want to do a little higher level, then there are higher levels as well. चाहिए a little higher, ज़्यादा नहीं, थोड़ा सा higher level. Like if I keep on placing masses at the vertices, I mean corners of a cube, how many masses can I place?
Sir, 6.
Now at the corners of a cube. Bolo? 8, yes. Now if all the masses are m, all the 8 masses are m. Cube का हर एक side है a. Each side of the cube is a. So let us understand the technique of doing that. How? Tell me what different types of distances the masses may be away from each other. How many how many distances and how many types of different distances that the masses may be away from each other.
3.
3.
Wow, this batch is very good. 3. And what are those distances in terms of a?
Sir, 3D the diagonal, the length, and the 2D diagonal.
So what are the values then?
A,
Huh?
root A, 3 root.
A,
A,
2 root A and 1 is root 3 root A.
very good. You were very good actually. Very good. These are the 3 types of distances. Like if we take a square face only this square face, any face, say the floor of the cube. So there are distances A and there are distances A root 2, the diagonal. This is called face diagonal. Okay, those terms are there, but 2 diagonals, A root 2 distance. And there are diagonals which are from the corner of this room, suppose ये कोने से वो कोना तक 3D diagonal, that is body diagonal. So if you can understand that, can you tell me how many A distances are present here between the masses?
12.
Wow, very good. 12. How many edges of a cube exist? Edges of a cube. 12. ऊपर में 4, नीचे 4 और 4 पिलर हो गया 12. How many A root 2 distances are possible between masses? How many times A root 2 distances are possible? Very good. Very good. 12. This is also 12. एक फेस में कितना डिस्टेंसेस पॉसिबल है? 2. ढींच के आओ एंड ढींच के आओ, ये तो हो गया. There are 2 such face diagonals for each face. So there are 6 faces of a cube containing 2 diagonals each. So total 12 diagonals. A root 2. And how many A root 3? Yes. Very good. 4. The room you were present, एक बार देखो, ऊपर का कोने से ऑपोजिट का कोना नीचे और उसी का नीचे के कोने से ऊपर का कोना 2. फिर घूम जाओ ऐसे, फिर ये साइड का ऊपर से नीचे का कोना और यही साइड का नीचे से ऊपर का कोना. कितना हो गया? 4 body diagonals. That means A root 3 वाला, there may be 4 distances. If you can understand this, साम तो बन गया. फिर साम में क्या रखा है? फिजिक्स में सिर्फ अंडरस्टैंडिंग. वंस अंडरस्टैंडिंग इज डन, फिजिक्स में और कुछ नहीं है. कैसे? टोटल ग्रेविटेशनल पीई ऑफ द सिस्टम वुड बी गिवन बाय माइनस जी कैपिटल एम स्मॉल एम सब तो सेम ही है. बोथ आर, I mean all the masses are smaller. So small m into small m. Suppose these 2 masses we are going to calculate. How much would it be? GMM means m square divided by the distance they are apart, A. How many such potentials, gravitational potential energies will exist? 12. That's why I asked you how many A distance cases may be there? 12. Similarly, minus GMM, that is m square, by A root 2. How many such? That is again 12. And how many A root 3? GM square by A root 3. That is 4. So this plus this plus this. This is the total gravitational potential energy. Now 4 तो समझ में आया, a root 3 कहाँ से हो गया? Phase diagonal. I think those who are doing mathematics know this. Otherwise those who are not doing mathematics, उसके लिए बता रहा हूँ. क्लास 9-10 में क्वेश्चन आता था, what is the maximum length of a rod that can be placed inside a room? And the answer was given by length of the room square plus breadth of the room square plus height of the room square. इसका root over. Otherwise, you can well understand, if the vector starting from origin, मान लो घर का ये कोना मेरा origin है और वो ऊपर का कोना में ये diagonal में draw करना चाहता हूँ, तो उसका coordinate क्या होगा? A, A, A. 3D है ना? तो A I cap plus A J cap plus A K cap. इसका वैल्यू कितना होगा? रूट ओवर ए स्क्वायर प्लस ए स्क्वायर प्लस ए स्क्वायर. दैट मीन्स ए रूट 3 इन वेक्टर टर्म्स. अदरवाइज ये क्लास 9-10 का हिसाब से रूट ओवर ए लेंथ स्क्वायर ब्रेथ स्क्वायर हाइट स्क्वायर. लेंथ भी ए है क्यूब का, ब्रेथ दैट इज ऑल्सो ए, और हाइट दैट इज ऑल्सो ए. सो अल्टीमेटली इट बिकम्स ए रूट 3. दैट इज द वैल्यू ऑफ द डिस्टेंस. एंड हाउ मेनी सच डिस्टेंसेस? 4. एनीवे, so this is the total gravitational P. How much is it coming? Just like this. In such cases, look for the maximum thing that you can take common. Minus common, gm square by a common. And then even you can take 4 common, no problem. 4 also can be taken common. So anyway, I am writing this 12 plus this one. I am writing 12 by root 2. That means 6 root 2 plus 4 by root 3. This is the answer. Again, you can take something common. At least 2 तो common जा ही सकता है इससे. But anyway, this is the answer. So this is a little higher level I was talking about. Okay, we have learned this. अब ये बता दो तो, if you have understood this. न छोड़ेंगे नहीं, जिसको सीखोगे, you are investing time, your attention. एग्जाम सामने है, तो this is your investment. तो उसको जीत के ही छोड़ना है. If you have started it, let us finish it. कैसे? चलो तो let's see how fast, how many, and whether or not you can do this. And as I have started drawing, most of you have understood what the question is going to be. You are waiting for what? The each side of a square. That is A. I knew you were waiting for this. And each mass is M. What is the total gravitational P of this system? Each side A. How many distances are there which are A only? 4. So A distance wala masses 4. 4 times. Hey, so this is 1, this is 2, these 2, and these 2. So we have to take these A distance wala masses 4 times. So what else? What else? A distance 4 times. What else can be another distance between 2 masses? A root 2. Yes, yes. Yes, A root 2. This also can be a distance between 2 masses. And how many such distances are possible? 2. How many diagonals are possible? 2 only. So, A root 2, 2 times. Bas, that is the answer then. That is the answer then. How? We will write P equals to minus G m into m, that is m square, divided by A. How many times? 4 times. Plus minus G m m, that is m square, by A root 2. How many times? 2 times. into 2. Now let us see what we can take common from this. Gm square, yes, A, yes, and then 4 plus, this is 2 divided by root 2. This is root 2. We can write the answer in this way also. Very good then. So up to school level, board level, this is okay. Beyond that, then also it is okay. Practice just. There is a mass 16 m. M is certain value of mass. And there is a mass m. Draw this. This is a planet of mass m. This is another planet 16 times heavier than that. I mean more massive. 16 times massive. Okay. They are separated by a distance r naught. They are separated by a distance r naught. Now write the question. Write the question. At what distance from 16m, from the 16m mass, will the gravitational field intensity vanish, means will become equal to 0. At what distance from the mass 16m will the gravitational field vanish? That means gravitational field will become equal to 0. What is that answer coming? In terms of R naught, E16 m, G capital M here will become 16m divided by, let the distance of that point P from 16m be x. So x square. And gravitational field intensity due to the mass small m, तो small m का gm by r square, g into उसका मास जिसका ग्रेविटेशनल फील्ड निकालने जा रहे हो डिवाइडेड बाय उसका डिस्टेंस. সেটা it may be r naught, हाँ,
minus 2 r naught plus r naught whole under root 4 plus 8 r naught whole divided by 30.
oh अच्छा, let's see that. So this is r naught minus x whole square. Okay, let us see that. Now this is r naught minus x. The distance of mass small m, this distance would be how much? R naught minus x, that distance. So now 4 by 5 R naught. So let us 5 by 4. 5 by 4. Okay. Okay. So let us see this. Now for at P, if a resultant gravitational field is 0, that means these two gravitational fields are equal and opposite. So let us put their values and make them equal. R naught minus x whole square. Now maybe some students make a mistake. That is not wrong. I am not saying wrong, but make a mistake at the exam hall perspective. It may not be correct to do what? Do not expand this term. R naught minus x whole square. If someone makes a square of this, bas gaya wo to. Otherwise, just make a square root of this after cancelling g and m. So Okay, so after this, let us do the square root of this. That's why I have given you 16. Now, square root of 16 is 4 divided by x square, square root of x, x. On the right side, numerator 1, square root of 1, 1, r naught minus x whole square. So, r naught minus x whole square, root over of that would be this much. Just square root both sides. Remember this, ever if you find these type of calculations, quite a few occasions you will be finding like that. So, from this, 4 r naught minus 4x equals to x, cross multiply, 5x equals to 4 r naught, so it is 4 by 5 r naught. Now, let us move on further. Let us move on further with satellites. Give heading satellites. Very, very important. Satellites. Satellites can be of two types. Number one, that means in our study. Number one, write polar satellites. And number two, write geostationary satellites. Geostationary satellites. So, polar satellites and geostationary satellites. If this is Earth, कैसा Earth? अच्छा Earth. If this is Earth, then if we want to think of a polar satellite, it would be like this. It would be orbiting over the poles of Earth. If this is a satellite, it has to orbit over the poles of the Earth. Like this. Their heights are less, 700 to 900 kilometer from the surface of Earth. Less height, ज़्यादा नहीं. अब less माने it doesn't mean so less that you can कि ये सैटेलाइट छत में चढ़ गए और सैटेलाइट जा रहा ऊपर से हाई हेलो किए कि भाई साहब कैसे सैटेलाइट ठीक ठाक, बोला हाँ उतना क्लोज नहीं. क्लोज माने 700 to 900 किलोमीटर. एंड देन अरे 100 मिनट्स में घूम के आ जाएगा अर्थ को. 100 मिनट्स में पूरा घूम के आ गया. हाई स्पीड सैटेलाइट्स, they are mainly used for spying over countries, military movement, cloud movement, weather reports. These are the functions of polar satellites. Okay, so these are the functions of polar satellites. Cloud movement means what? Rain, forecasting, those things related to rain and all those things, and military movement. Then spying, you should not write it in the exam. Okay, they are used for spying over countries. That you should not write that. But these are the applications of polar satellite. They fly very low, but flying high are the geostationary satellites, जिसका हम लोग we will calculate. How? तो देखो, we have to draw this. The geostationary satellites move around the Earth from west to east. Why? Because Earth moves like that. ये Earth को copy करेगा. Similarly, they have same time period as that of Earth. Earth's rotation about its own axis I am talking about. So Earth rotates with respect to its own axis from west to east, ये भी west to east. Earth rotates within 24 hours, ये भी 24 hours. So its time period is 24 hours. That means its omega angular speed should also be equal to that of Earth. Omega, क्यों? Omega माने तो 2 pi by t, 2 pi by time period. If time period are same, then omega angular speed will also be same, that of the Earth and that satellite. मान लो कि this is a satellite जो कि है नहीं, और ये जो कॉर्क है, ये कॉर्क का सामने I placed my finger like this. Now if this rotates and my finger also rotates with same speed like this, then what will happen? My finger will always be above this. इसको मान लो अर्थ, इसको मान लो सैटेलाइट. So if a satellite rotates in the same direction with same angular speed equal to that of Earth, then the satellite will always appear to be on the sky of this place stationary. ताले ये ऐसे घूमता जाएगा ऐसे, तो ये हमेशा लगेगा कि it is over this. Both are rotating, that means there is no relative rotation. एक साथ घूम रहा है ऐसे. So होता क्या है जियोस्टेशनरी सैटेलाइट में? राइट, it appears to be stationary with respect to be stationary with respect to a certain place on Earth. With respect to a certain place on Earth. Or number 4, that is a must. Number 4. Before I write this point, let me tell you the question. एक बार IIT में ये आया था, is it possible to launch a satellite geostationary on the sky of Delhi? On the sky of Delhi. Delhi से क्या मतलब है? अब Delhi कर पाएगा नहीं कर पाएगा हमें क्या मालूम? We know this. Why? Point number 4. Along the equatorial plane, this satellite can rotate or should be placed along the equatorial plane only. And if Delhi or any place lies on the equator of Earth, then we can place a geostationary satellite over the sky of that place. So we cannot place it on the sky of Delhi. This is the 4th point. Point number 4. And another information about this geostationary satellite, another information, that is the orbit along which it is placed is called parking orbit. Parking orbit. The orbit of a geostationary satellite is called parking orbit. With these informations, parking orbit, these are informations. Now we are studying physics. It is not only informations. Calculations are also there, simple calculations. And for that, we need not to learn anything extra. What is that? Chalo, this is the part. First, draw Earth and draw a circular path along which a satellite is, this satellite. This is orbiting. This is the radius of the satellite from the center of Earth, remember, from the center of Earth. Otherwise we take this to be, and you need to understand this, radius of Earth. This is the radius of Earth, this distance. is the radius of Earth, and whatever distance is above that up to the satellite, that is the height of the satellite from the surface of Earth. That means what? ये पिक्चर अगर कॉम्प्लिकेटेड लग रहा है तो इसको समझो. When the satellite comes to this position, this is the radius of Earth, capital R, and this is the height of the satellite from surface of Earth. So can we say this thing? Radius of the satellite from the center of Earth is equal to radius of Earth plus the height it is above the surface. Small r equals to r plus h. You have to understand this. And capital R is very large. और h और large हो सकता है, नहीं भी हो सकता है. तो चलो, if you have drawn this, let us start the calculation. मैं फिर से इसको draw करना चाहता हूँ because I understood that drawing like that may create some confusion. उसलिए मैं ऐसे draw कर रहा हूँ so that we can understand this. Okay, this is r and this is h, so that this distance is r plus h, which is called the radius of the satellite, and this is the satellite. ठीक है, चलो कैलकुलेशन में क्या है, कुछ नहीं है. Centrifugal force m v satellite square divided by small r. चलो हो गया. And this planet or Earth that will attract the satellite, with gravitational force. So write F gravitation, Fg, that means gravitational attraction. ये एरो बहुत खराब हो गया. ये ठीक, Fg. Okay. So for dynamic equilibrium of the satellite, that means ये same orbit में घूमता रहेगा satellite. What should be there? F gravitation, gravitational pull should be equal to the centrifugal force. From this we can write gravitational force G capital M, इसका मास capital M लिखना, small m, satellite का मास small m लिखना, divided by radius square. एक रेडियस को तो कैंसिल कर दो, कैंसिल वन रेडियस, एक स्मॉल m कैंसिल. So from this what we get is velocity of a satellite. मिल गया, root under capital G capital M by small r. मिल गया, very important formula. In other words, V is given by root under capital G capital M divided by radius plus height. Small r is equal to radius plus height. This is the orbital velocity of a satellite. Orbital velocity of a satellite. रूट ओवर जी एम बाई आर प्लस एच. ये पेज तो हो गया, सिर्फ ये लिखो नीचे, इफ द सैटेलाइट, स्पेशल केस, इफ द सैटेलाइट टेक्स फूड एंड वाटर फ्रॉम आवर रूफ ऑफ द बिल्डिंग, ऐसा नहीं, मतलब इफ द सैटेलाइट रिवॉल्व्स at a very low height, so that h is very very less than capital R. Very low height, very low, थोड़ा सा low, more, इसका तो कोई वैल्यू नहीं है unless you give a comparison reference. तो यहाँ पे रेफरेंस कौन है, रेडियस ऑफ अर्थ, अर्थ का रेडियस से भी बहुत कम हाइट में जा रहा है, वेरी लेस हाइट। तो देन व्हाट विल, লাস্ট পেজটা এটা এটা বলছো, ওকে ওকে ঠিক আছে, নেক্সট পেজে যাচ্ছি চলো। তো ইফ দিস ইজ সো দেন ভি ইকুয়ালস টু রুট আন্ডার জি এম, তো ওকে, by r plus h we have neglected h because h is very very less than r, so let us neglect h. So v would be given by root over gm by r only if a satellite rotates very close to the surface of earth, or sometimes but not all the times, and that is not correct. This is more correct, I am telling you. Sometimes we can replace it by this thing. It is given in books, but this is not all the time correct. Why I am telling you? General manager equals to gr square. Why? Because we knew this. G equals to general manager by r square. We knew this. So general manager can be replaced by gr square, and we have replaced this general manager by gr square. So r cancel. So it is root over gr. Well, we can write this provided h is very very less. The time period is found like this: 2 pi r by t. Time period not only for satellites, anything that goes in a circular path, the time period can be found like that: 2 pi r by v. How? So as it is moving with same speed, so distance equals to vt, right? No, same speed is. So t is given by, time is given by s by v. Now s for a complete circular path is how much? And the speed. And for a complete circular path, what is the time taken is called capital T. That's what it is. Chalo. Let us do this. 2 pi r by v. So t equals to 2 pi. Chalo, फटाफट करते हैं. R divided by v. V means just now we have found gm by small r, and small r was equal to r plus h. Same thing. So equals 2 pi r cube by gm. Again, those who don't feel it very good, welcoming. R divided by 1 by root r can be written as r root r. When this r goes inside the root over, it becomes r square. And there was one r waiting for it to welcome it. तो कितना हो गया? तो ये जो पार्ट है, ये इसका साथ और इसका साथ हुआ. ठीक है? इसका साइड. As this is like this, we can easily find this time period to be 2 pi root over r plus h. Now let us put r plus h in place of small r. This is the formula for time period. नीचे write one line that may come to be proved during exam. क्या? Or in MCQs also you will find. Velocity, orbital velocity, and time period of a satellite, মানে geostationary. ये फॉर्मूला में स्मॉल m है नहीं है, there is no small m in this formula. Let us go to the last page. Look at here. Small m cancelled at the very first line. That's why the speed of the satellite and the time period of the satellite does not depend on the mass of the satellite. So there is m, but this m is the mass of the planet. And here on this chart, right, another thing about geostationary satellite, these all may come as short questions or MCQ. What? The height of this geostationary satellite is nearly 36,000 kilometers. 36,000 kilometers. Okay, so this was the time period. Now, let us do heading down. Main part of this, we have reached the final part. Energy of a satellite. Kinetic energy. Let me write smaller. Oh, I have written kinetic energy again. This is potential. Follow? अच्छा ना with sign see, and I'm telling you what type of questions may come from this. Peter with sign, take P with sign, so it would be GMM by 2R plus minus GMM by R. Yes, that is also correct. So it is minus GMM by 2R. Total energy. I'm using some color. Try to visualize this. Is this thing coming everywhere. What changes is a number. Now we can write this as half of, if I write GMM by R, suppose I write anything, say I'm writing E naught. So this is half E naught. This is how much then? Minus E naught. And this is how much then? Minus E naught by 2. That is minus half E naught. So we see, let us analyze this, okay? Let us analyze this. We see that kinetic energy, therefore half, so okay, mass cannot be negative. V being a square cannot be negative. So this is always going to be positive. And same value of, now value, same value of kinetic energy is the total energy. Value same. Only there is a negative sign in total energy. And as I had told you, negative sign in energy means a bound system. That is, a satellite is bound to Earth. It cannot move away from it, leaving the Earth behind. रोता हुआ Earth को छोड़ के टाटा करके नहीं जा सकता है, because it is bound to Earth. That's why the total energy is negative. And the comparison between them is, you can remember, you have to remember this, huh? You have to. Why? Because it is again coming in electrostatics. In modern physics, when we would be doing atomic structure in physics. So there again it is coming in great detail. So try to remember this, it will help you there also. How? Say if kinetic energy का बात करें, तो kinetic energy and total energy are equal, but kinetic energy always positive होगा और total energy उतना ही होगा but negative होगा. बस इसको याद रखो. और potential energy double of this. Total energy double. Notice करो. E naught by 2 into 2 is E naught. Sign same. And for further help, it will definitely help you. If you make a visual, say this is 0 height, this is 0, I'm telling you. ना यहाँ पे नहीं होगा. Next page में. If this is 0 height, and this is kinetic energy, I mean 0 energy is 0. This is kinetic energy. So this much should be the potential energy. Negative of that and double of that. If I don't give this, if I draw this like this, then it will be like this. Just double of that, 2 units, but negative. And what about the total energy? This is potential energy. Negative and double of this. What about the total energy? Negative but equal to kinetic energy. This is a pictorial representation of energy. If we take this to be 0, so this would be negative. And let us also write the values side by side. This will definitely help you remember this. So this would be GMM तो सब में होगा. याद है I had taken that common. GMM, it would be 2R. 2 means नीचे 2 माने less. And this would be negative. GMM तो सब में होगा. Ke and total energy equal, potential energy double, and Ke positive, total energy and potential energy are negative. If you understand this, then you can obviously understand this. And I'm telling you the technique of drawing this. If you need to draw somewhere or in MCQs, if you have to find this, which one is correct, like that. So draw energy along y-axis and along x-axis the distance smaller along x-axis, and then draw this thing. And this is kinetic energy of a satellite. Now why is this graph looking like this? Because of simple thing I had told you in that video, याद है 11 का शुरू में video, graph. If A proportional to 1 by B inversely proportional rectangular hyperbola, and by now as you have or you are doing maths, you definitely understand. Otherwise simple one. Inversely proportional rectangular hyperbola. Now where is this inversely proportional? ये तो है Ke का formula. GMM divided by 2 into R. If you look at these two things, how are they related? They are related inversely proportional. K inversely proportional to R. That's why rectangular hyperbola. Now, I had also told in that graph part in the video, kya? Ki if you place a minus sign before a graph that you already know, then the graph will become or give you a mirror image. याद आ रहा है? If you just place a mirror below that, so if I put a minus sign here, just below it, if I write a minus sign, that is say total energy is minus GMM by 2R equal to kinetic energy minus GMM by 2R. Just इसी का minus है. So if there is a minus sign, then just place a mirror below it. How should this graph look like in the mirror? Just reverses. This is the total energy. Understood? Now, what would be the graph of potential energy? It will again be negative, so it will come in negative side of the graph, negative y-axis. Why? The sign was negative. But its value would be somewhat its value is just double of that this kinetic energy, total energy, and kinetic energy also, but kinetic energy positive and potential energy negative. So draw a graph just like this. This is potential energy. The technique of drawing this, or technique of understanding if it is given in exam. What is the technique? This height above x-axis, same depth below x-axis. ये इतना ऊपर, ये उतना नीचे. That is equal, symmetric graph. कौन सा होगा? Which two are equal in this part of this three? K and total energy. One positive, one negative. So K and total energy. And the distances I have drawn here, उसका double distance अगर कर दूं नीचे, तो काइनेटिक एनर्जी का डबल एनर्जी किसका होता है? पोटेंशियल एनर्जी का, बस नेगेटिव बस, बट काइनेटिक का डबल, दैट मींस दिस इज पोटेंशियल एनर्जी. सो ऐसा करके जब व्हेन यू फाइंड एमसीक्यूज इन एग्जाम्स कि ये ग्राफ नंबर 1, ये ग्राफ नंबर 2, ग्राफ नंबर 3, ये 1 खराब हो गया, दिस इज नॉट अ गुड वन. ऐसे 1, 2 and 3, what are represented by these three graphs? If y-axis represents energy and x-axis represents distance. So 1 is kinetic, 2 is Total 3 is potential. So these are the ways how questions can be formed from this graph world. Okay, so this is the graphical representation, KP, of satellites. So, and PE of satellites, did you understand this PE of satellites? Where did we find this formula from? We had done potential energy of two masses. So here is a mass small m, satellite orbiting around Earth, and here is a mass capital M. What would be the PE between them? Minus G m1 m2, that is capital M small m, divided by R. That's why we are writing this PE. So anyway, this was the energies of a satellite. Now let us do one more interesting, probably, no, I would not say like that. This is very important, I would say. Why? Because this has escape speed or escape velocity in our books we find, but good is escape speed. So anyway, whatever comes in the question, you write like that. I'm writing escape speed. Escape speed of what? Satellite? No, for any object. How can it escape the surface of Earth? We will not require to, good news is, we will not require to integrate this. Unlike books. Books में जैसा किया हुआ है नहीं करेंगे. We'll follow easier method. I'm showing you. Number 2, good news. That is, we need not to learn anything new for this. We just need to apply whatever we have already learned. So those are the good news. चलो शुरू करते हैं. Let this be R. Oh, the best art I have ever drawn. Anyway, center O, radius R. It has a mass m. Place an object here. This object has a mass small. Robert, मेरे साथ सब. Now, this object would be having a potential energy. How much is that? Minus Gmm by Gmm by small r. Now, small r is equal to capital R here. The distance between the two centers of two masses is how much? Capital R. Okay. So this would be the potential energy of this mass. Now, along with that, if you give a velocity to this v, that means you are throwing this mass. So you are adding kinetic energy to this. So how much is the kinetic energy? Half m, then v square. Half m, then v square. This is the kinetic energy. Now, if you give it a kinetic energy so that it moves beyond the gravitational field of Earth or the planet, any other planet, Earth or any other planet. Now, do we know up to what distance the gravitational field of any mass exists? Gravitational field. Up to what distance? The gravitational field extends up to infinity. That means if you have to move a satellite or any object beyond the gravitational field of Earth or any planet, you have to provide it with a velocity that can take it to theoretically infinite, practically a large distance. So infinite. So let us give it that speed which can take it to infinite distance here. And reaching that point, its velocity becomes 0. Now consider this situation. You have thrown an object that moves. If I throw this pen like this, so the pen will again fall on my hands. But if you throw this, it will not come back to Earth because it has moved beyond the gravitational field of Earth. So intensity of gravitational field at this position is 0 now. It will not return. Then even if its velocity now becomes 0, still it is not going to come back. Now, suppose this value for Earth after calculation, we know that this value for escape velocity for Earth is 11.2 kilometer per second. We know it's that 11.2 kilometer per second. But my question is what? My question is, suppose it takes 100 rupees to avail a taxi so that you can reach point B from point A. Now what if you have 200 rupees, 300 rupees, 1000 rupees, 10,000 rupees? Can you go to B from A? Yes. But here answer. But what is the minimum value of money that can take you point B from point A? That is 100. So what is the minimum velocity with which you should throw an object so that it can reach the infinity? Is the situation where you have given the velocity and after reaching infinity, its velocity decreases and just becomes 0 after reaching infinity. But if you throw it with more the velocity, so it will reach infinity though for sure, but still it will be having some velocity still left with it. But that will not be called escape speed. That is what I am trying to say. Escape speed is the minimum speed with which, just write it, with which a body must be projected so that it can move beyond the gravitational field of Earth or any planet. Is called escape speed, or if you find in exam that it is escape velocity, then it is escape velocity. Otherwise, escape speed. So this is the escape speed, which gives us this picture. Picture says 1000 words. Pictures ko yaad rakho. V speed given after reaching infinite distance, its velocity becomes 0. Okay, remember this. Remember this. Now, what is the calculation? Just we have to change this velocity to VE, V escape. So, I'm doing the calculation on the next page. You remember this? See this thing. Just look at the picture and look at the values. So the calculation begins. What calculation are we going to do? We are going to do energy balance, that is energy conservation. Remember this, to deal with such numericals which may be sometimes a little tricky, and for mains IIT, you need to have clear concept of this, basic concept but clear. What is that concept? Energy conservation. Why do we conserve energy? Why? Because non-contactual forces, the forces which do not require contact between two bodies, are always conservative. Now it may also come in an exam, what is conservative force and what is non-conservative force. If the work done by a force or by the influence of a force can be regained, work done by a force or by the influence of a force can be regained, फिर से वापस मिल जाएगा, total work done, then that force is called, work done now, force is called conservative force. And non-conservative force, when you did some work by that force, और जो वर्क डन खत्म हो गया उसको बोलो भाई दे दे वापस, अब तो हो गया, वो बोला नहीं हम नहीं देंगे, गया. That means the work done by the influence of a force cannot be regained. That sort of type of forces are called non-conservative forces, like friction. If you pull a body against friction, you did some work. You again pull it back to the same point. Again you did work, but that work done is not returned. Double kharcha ho gaya. But if you pull an object above the surface of Earth, you will do some work. mgh. Now if you release it from there, it will come back to Earth, giving you back that mgh in the form of kinetic energy, half mv square. So gravitational field is conservative field. Electrostatic field, conservative. Magnetic field, conservative. 3 fields in our syllabus. Remember that. And for those cases, we can always balance a conserve energy. Okay. So let us do energy conservation. Okay. So energy at the beginning, at this position, say energy at this position, A, and energy at this position when it reached infinite distance, B. Let us conserve and make the energies equal at these two positions. Energy at A, half mv square था ना, half mv square. Potential energy minus gmm by the distance between the two were r, equals to kinetic energy when it reached the infinite distance, 0, because its velocity became 0. Potential energy 0. Potential energy 0. How? Potential energy at B minus gmm by r होगा तो what is the value of r? R has already become how much? Infinite. So anything by infinity in physics, we will take 0. Anything by infinity. So potential energy, that's why 0. So how easy it became? This minus this equals to 0. That means what? This should be equal to that. But, khatam. That's it. Small and cancel. Feel good. And from that, just find VE from here. This 2 will go there. It would become 2 gm by r. Root 2 gm by r. जाना पहचाना लग रहा है, इसका आसपास कोई एक फॉर्मूला मिला ना, चलो तो चेक कर लो. यहाँ पे नहीं है, यहाँ पे नहीं है, यहाँ पे नहीं है, यहाँ पे भी नहीं है, यहाँ पे है. This formula from today onwards will be known as Samriddha formula. Due to the decoration part. Okay. So we gave a Samriddha decoration to this. So this is that formula. V equals to root over gm by 1. When does this happen? This is the velocity of a satellite only, P only, not for any object or body, but it is for a satellite which revolves in a radius capital R being very close to the surface of Earth, capital R being radius of Earth. Okay. So if a satellite is projected, its velocity is root gm by r. a satellite is projected, look at this picture. If I draw this to be R, and if a satellite revolves being very close to the surface of Earth, there is a satellite. Its velocity, tangential velocity, is given by root over gm by r. There is a closed satellite. Radius of Earth. There is a closed satellite. Its speed is root over gm by r. Now we want key, and we have wanted this so many times. कब satellite का खत्म हो गया life. Satellite has grown old. We don't want this satellite further. So we do what? There are so many satellite debris in the space. There are at least right this time more than 30,000 satellites orbiting the Earth. So there are satellites which need to be disposed of their path. How to do that? We will increase their speed. 2. If we increase their speed to this much, this speed is what speed? Escape speed. So if you increase the speed of the satellite to escape speed, it will escape. कैसे? सीधा निकल जाएगा ऐसा नहीं. It will start moving in a greater orbit, I mean of more radius करते करते ये निकल जाएगा to beyond the gravitational field of Earth. ये निकल जाएगा satellite. तो question comes, what percentage increase is to be done to the speed of orbiting satellite so that it moves satellite so that it leaves the Earth forever. उसका आंसर एक लाइन. Yes, yes. रुद्राक्ष में चलेगी. रुद्राक्ष में बोल रहे. Okay. हाँ, तो what time देना? देर तुझे बोलो. Yes. And how is that? We have to just increase the velocity from this to this, and we know percentage formula. Again I am telling you, final value minus initial value by initial value into 100. That is simple formula of percentage. Final speed has to be done this much. How much? Root over 2 gm by r minus initial speed this much. Only root over gm by r divided by initial speed whole this thing. बहुत बड़ा calculation होगा. It may take some 10 seconds or less than that.
Yes, 41 minutes.
Still good. Or less than that, very easy. Take these things common. Take these things common. Root over gm by r taken common. So root 2 into root over gm by r by root over gm by r. Only root 2. Minus root over gm by r by root over gm by r. 1 into 100. Now root 2 means 1.4142. Minus 1, that is 0.4142 into 100. So 41.4 near. 1.41 minus 1, so 0.41 into 100, that is 41%, but that is 0.4142. So 41.4%. In exams or in MCQs, you may find this to be 42% near. So take that 42%, that is the correct answer. But if you have to do this theory part, then this is 41.4%. This is the sum. Important sum. Huh? So that was one more part. And about launching the satellite, before we go to the last part of our class is going to end. One thing just remember, suppose this is a launching pad of a satellite, or suppose this is a tower, simple, so tower. Now from this tower, if we throw an object with a small speed, it will move some distance and again fall on Earth. If we throw this object with orbital speed, then it will move in orbit if the speed is higher. If we throw an object with more than that speed, it will move again in this path. And more than that, velocity for making the satellite move in a circular path was the orbital speed, gm by r plus h. Gm by smaller, yeah, the capital R plus h. This is the orbital speed. If you throw less than that velocity, it will fall on Earth. And this trajectory is parabolic. This trajectory, parabola. This trajectory, circular. More than that, elliptical. And beyond that, escape velocity. R plus h. Or you can simply write R. Hyperbola. क्या बोला? Hyperbola. So for elliptical path, the velocity should be in between these two, circular and hyperbola. So velocity here should be greater than v orbital but less than escape speed. Then it will be moving in an elliptical path. Drawing अच्छा नहीं हुआ, please don't mind that. ये एकदम ellipse नहीं हुआ, बहुत ही खराब ellipse हुआ है, very bad ellipse. Anyway, so technique याद रखो बस. This is the part and the last part was shooting. चलो, have you drawn this? So let us move to the last part. Here drawing, and this is Earth. Okay. चलो, last part of this. Kepler's laws. First law. Picture draw. Picture helps you remember. Understanding तो है ही. Remember करना में भी help करता है. planets move in, थोड़ा लिख लो, planets move in what path? Elliptical path. Keeping sun at one of its foci. इलिप्स का दो फोकस होता है, कोई ना कोई एक फोकस में सन है। अब प्लेनेट को बोलेगा ठीक है आप घूमो, अब मुझे फोकस में रखो भाई, नहीं तो घूमने नहीं देंगे। That means there may be another planet जो ऐसे मूव करेगा, there may be another planet जो ऐसे मूव करेगा. In all the cases, these ellipses, they have sun at one of their foci. That is the meaning of this. So that was the first law, very simple, and we knew this. The second law is aerial velocity of a planet is constant. Aerial velocity is constant. And write this thing. dA by dt equals to L by 2L. If you don't have an idea of capital L right now, we will be doing in the next class angular momentum. So we are not going in detail of this. Just write this L by 2M. Angular momentum by 2 into mass of the planet. M is mass of this planet. M. This would be the aerial velocity. And what is the meaning of this aerial velocity in simple terms? In simple terms, it will mean aerial velocity, area swept per unit time. Unit time may be 1 second, 1 minute, 1 hour, 1 month or 1 year. कुछ भी हो सकता है. Area swept per unit time by the radius vector is constant. This can be other form of writing the second law. So velocity means anything done per unit time. That is velocity. So the area made per unit time is called aerial velocity. And how is area made per unit time? Suppose the planet was at P1 and you started looking at the planet every night. Then you said that. After 1 month you saw the planet to move to P2 from P1. So this is the radius vector, distance. So the radius vector moved from here to here ऐसे करके, जैसे कि झाड़ू लगा है, इसको स्पेस में झाड़ू लगा, तो कितना एरिया झाड़ू कर दिया? This much area has been described or swept by this radius vector ऐसे करके. तो ये जितना एरिया स्वीप किया, सपोज यहाँ से यहाँ तक आया, you watch the planet for 1 month. So 1 month को मैं बोल रहा हूँ T1. अब एग्जाम शुरू हो गया, you didn't find enough time. तो बाद में maybe after 2-3 months or 6 months you started looking at the planet. तब देखा रे planet तो यहाँ पे आ गया. So the radius vector is this much. And then you watch the planet for another 1 month. That is another time. 1 month, same time. तो तब तुम देखे कि अरे planet तो यहाँ तक चला गया. That means the area, the radius vector, कितना area sweep किया, इतना. So according to the second law, aerial velocity same मतलब, if you are taking same time for watching the motion of this planet, then the second law tells us if time taken equal T1 equals to T2, equal time for observing the motion of the planet, then the area described by planet should also be equal. If this area is taken A1 and this area is taken A2. एक सिंपल बात बोलो, a triangle सोच लो, half base height, व्हाइट कलर का ट्राइंगल का हाइट ज्यादा है क्योंकि बेस छोटा है P1 P2, और ये पिंक कलर का ट्राइंगल को देखो, इसका बेस भी बड़ा है, हाइट छोटा हो गया compared to the white one, so its base should increase so that area of the two triangles, ये triangle perfect नहीं है, फिर भी consider करो कि area of these two should be equal अगर time same है, so that means area बनाने का जो speed है, that is called aerial velocity. Aerial velocity of a planet is constant. इससे ये we can even calculate this. इससे और एक चीज होता है क्या, as we don't, I mean, if you haven't done this angular momentum part, otherwise, the mass of this planet is going to remain the same. That means angular momentum भी same ही रहेगा. So angular momentum कब same रहता है? If no external force acts on a body, then linear momentum is conserved. If no torque applied on a body, if no torque is applied on a body, then angular momentum is conserved. तो अब जो planet घूम रहा है उसको कोई बाहर से आके तो टॉर्क नहीं दे रहा कि जोर से घुमा दिया planet को. ऐसे हम लोग ठीक ठाक जा रहे थे, अर्थ जा रहा था, any other force turned earth faster. ऐसा तो होता नहीं है. That means as no torque acts on earth or any planet, so the angular momentum remains conserved or constant. So if it is constant, just take this part from here. If you haven't done that part, just take this part from here. What? Angular momentum mvr. So if angular momentum is conserved, then mvr remains the same. Now mass of the planet remains the same at any position of that elliptical orbit. So m1, m2 cancel. So what we find that v1 into r1 equals to v2 into r2. Here r1 and r2 are what? Maybe r1 is this distance, r2 is this distance. Radius vector, distance. So one very important idea we get from here, and maybe questions set from this part, that is what? As the radius decreases, to keep this product same, the velocity must increase. See here. The distance of the planet at P3 and P4 has decreased from Sun at S. So the speed of that planet at those 2 points, speed जो है, that should increase. That is, यहाँ से planet जब जाएगा, suppose its velocity is v2, and when the planet was moving from P1 to P2, say with a velocity or speed v1, then if we compare that v1 moving at a greater distance, v1 का क्या है, distance greater है, तो speed क्या होगा, less. Speed क्या होगा, less. So ये आम questions है, very common questions. Okay, this is Sun and this is P1 position, this is P2 position. P1 position where planet was moving with the speed v1, P2 position where the planet is moving with the speed v2. Which speed is greater? अब R1 R2 दिया हुआ नहीं है, but we can easily understand from this picture what should be R1 and R2. कि R1 much greater and R2 much smaller. We understand it from picture. That means V2 must be higher than V1. That is it. Third law, you maybe know this or you have known this now. ही सीखे, अरे सीखे कब, बोले ही नहीं कुछ, नहीं आज ही सीख गए. You have already done this. Cannot remember. Okay, मैं दिखा देता हूँ. Have we found the time period of a planet? Time period T is satellite का भी तो निकाले ना, satellite का. तो same thing will be applied for a planet also. 2 pi root over small r cube सिखाए नहीं थे, मैथमेटिक्स सिखा रहे थे तब. root over r cube by gm. We found this. So if we square both sides, what we get? We get this thing. Now this part, mass of the earth, capital G, 4 pi square constant. So if you remove these constants, then you get T square proportional to R. Now in some cases, you may be asked to derive Kepler's third law from Newton's gravitational law. And you know where you should start from? You should start from that balancing of satellite. Remember, mv square by r equals to fg. We did this. Start from here. Find velocity v from here, root over gm by r plus h. That is smaller, root over gm by smaller. And then put the third line only. Then put t equals to 2 pi r by v to reach to this line. And then just square that, get this answer. That means up to this part, do this part. And then just do this. GM, sorry. ठीक है. Square टा दियो ना. तो वो भावना. GM. 4 pi square by GM. अच्छा ये t square versus r cube का ग्राफ कैसा हो सकता है? What would be the nature of the graph? T square versus r cube. But any known? Yes, very good. Very good, because t square is a single term, r cube is a single term. Those are placed along x and y axis. And they are proportional to each other. Straight line. Very good. So anyway, practice some numericals from this chapter. That will help you. And all the best for your exam. Okay? Bye.